So let's look at what happens with hydrogen when it reacts with different elements. Most important reaction, no doubt, is reaction of hydrogen with oxygen. It results in release of very large energy, and the only product is water molecule. The flame of hydrogen is colorless, and it has very high temperature, thousands of degrees Celsius. Now just photo of space shuttle main engine, where hydrogen burns with oxygen, producing invisible flame at full thrust. You cannot see it even when its enormous power works. This reaction can go by itself in a very elegant design made 200 years ago by the briner, so-called the briner lamp, that was very popular before electricity came into picture and usual matches and lighters came into picture. What happens here is that hydrogen that is produced by reaction of metal with sulfuric acid is coming in contact with platinum sponge, which is simply platinum metal with very developed powdered-like surface. When in contact with platinum, hydrogen molecules break into atoms that easily react with oxygen of air, producing flame and heating this sponge. As a result, you see light from the sponge, not from the flame, of course. And you have a lamp, and alternatively, you can use it as a lighter. You may want to look at this video that shows the design. Hydrogen is very attractive fuel, of course, because of high purity and cleanness of the product of reaction, which is again water. Specific enthalpy per kilogram is much higher than any other fuel. The problem is that energy density per volume is relatively low. You do not want to have your gas tank 5 times larger than, or even 15 times larger than your usual tank. So for many uses, that's a perfect fuel. For modern transportation, it is not. Anyway, that's one of options of energy storage. Even more attractive is use of hydrogen in fuel cells. The idea is that when you run a fuel cell to produce electricity, you have much better efficiency than an internal combustion engine. In internal combustion engine, you never have even close to 40%. With electrical power generation, you have almost 100% theoretically. You are not increasing the temperature of universe. You are not wasting energy on heating the surrounding. So the idea is that hydrogen gas comes in contact with air and makes H2O, the same reaction, but it is done on cold, with H plus ion being transported through membrane from H2 to H2O side. Alternatively, the same process can be done using CH4, then making hydrogen by usual hydrogen synthesis process, and in next step hydrogen goes through membrane cell to produce water and necessary electrical energy. Unfortunately, again, it is too heavy to be run on most of existing vehicles. Now, what are the reactions then with oxygen? Hydrogen easily reacts with any halogen. So, for example, with fluorine, it's almost explosive, but you can run with chlorine, with bromine, with iodine. It's a so-called chain reaction, resulting in formation of hydrogen halogenides, so HF, HCl, HBr, HI. Hydrogen reacts with nitrogen to make NH3, will react with sulfur to make H2S. Hydrogen reacts with oxides, for example with copper oxide, to make water and element, metal. Hydrogen always reacts with unsaturated organic compounds. This is ethylene or ethene, double bonded, to make saturated aliphatic hydrocarbons. You can reduce triple bond, same way. Hydrogen also reacts with oxygen-containing organic compounds. We have different types of element hydrogen compounds. Compounds with nonmetals and some metalloids and some metals actually are covalent. So starting with boron, aluminum, gallium, and then tin to iodine, lead, bismuth. All these compounds are covalent. Now, compounds with first and second group are ionic. In the middle, they are metallic compounds, so hydrogen jumps into crystal structures, still making compounds that have properties of metals. Let's look at ionic compounds. Hydrogen minus ion is like helium. It has 2 electrons on it, and it's very large. The radius is 1.5 angstrom, compared to oxide O2 minus, which is 1.4, and fluoride, which is 1.33 angstrom. Hydrogen, an ion, is very large. Now, compounds like lithium hydride, sodium hydride, rubidium hydride, cesium hydride, they have rock salt crystal structure, exactly like sodium chloride. MgH2 had the same structure as Pb2. Calcium hydride, strontium hydride, barium hydride have different structures. These hydrides easily react with water to make hydroxide and release hydrogen gas. They are very strong bases in absence of water. Very interesting is interaction of hydrogen with palladium metal. Palladium metal can absorb almost 1-to-1 molar ratio of hydrogen atoms. It looks like it makes compound PDH. In fact, it is not a compound. It's more like alloy. But what's important that hydrogen can be easily dissolved in palladium and as a result can diffuse through thin palladium layer. We can use this in order to purify hydrogen. So what we do, we run hydrogen in a furnace at high temperature through the tubing, and only hydrogen can penetrate through palladium alloy inside the tube, this tube. So you'll have H2 molecules only. It's absolutely impossible for any other molecules to go through metal tube. Imagine you have a metal tube and molecules are just coming through. All other impurities and any foreign stranger molecules will just be flushed out. As a result, you have fantastically pure hydrogen.